Welcome to the deep dive. We're really thrilled to have you here with us today.
Yeah, glad you could join us for this one.
Because if you are someone who is, fascinated by how human analytical intelligence is actually measured.
Or if you just want to understand how to rapidly make sense of a really data-heavy world.
Exactly. You are in the exact right place today. We are essentially handing you the ultimate cheat sheet.
The master key, really.
We are looking closely at excerpts from the Comprehensive Guide to the AP Statistics exam. But, and this is important, our mission today isn't just to read through a dry syllabus.
No, definitely not.
We are going to completely decode the architecture of this 3-hour exam. We want to act as your personal study strategist so you understand exactly what it takes to succeed. Because it really acts as this fascinating microcosm of how society evaluates critical thinking.
Exactly. Understanding the structure of a rigorous assessment like this one is, it's often just as important as understanding the raw material itself.
Right, because it's not just about what you know.
Exactly. It is about knowing where to invest your cognitive energy, how to pace your thinking, and what the evaluators are truly looking for when they attempt to quantify your reasoning skills. This exam is a masterclass in assessment design.
And to understand what they're looking for, we have to start at the very foundation. The source material outlines 3 overarching big ideas that ground the entire exam.
The philosophical pillars.
Right. Everything you do on test day, every single calculation you punch into your calculator, comes back to these 3 concepts. The first is variation and distribution. The second is patterns and uncertainty. And the third is data-based predictions, decisions, and conclusions.
What's fascinating here is that these aren't just bullet points on a chalkboard. They represent the entire philosophical foundation of statistics. They aren't just, mathematical formulas to memorize.
Right, it's bigger than that.
They represent a framework for how to think critically about the messy reality we live in. Variation in distribution acknowledges that the world isn't uniform. People have different heights, stocks have different returns, medicine affects patients differently.
It's a noise in the system.
Exactly. And patterns and uncertainty is our attempt to find the actual signal in all that noisy variation. Recognizing that because of that variation, we can never be 100% perfectly sure of anything.
Which is terrifying for some people.
It is, but that's the reality of data. And then data-based predictions, decisions, and conclusions, that is the ultimate payoff. It is where we take our understanding of that uncertainty and actually use it to make a concrete choice in the real world.
Okay, let's unpack this, because putting that philosophy to the test requires a serious gauntlet.
A literal marathon.
Yeah, the fundamental structure of this exam is a 3-hour marathon, and it is divided into 2 main sections, a multiple choice section and a free response section. And what really stands out right away to me is the scoring weight.
It's perfectly balanced.
It is a perfect 50-50 split. Half your score is multiple choice, half is free response. It reminds me a bit of taking a driving test.
Oh, that's a good comparison.
Right, because the multiple choice section is like the written exam, testing if you know the traffic laws, the signs, the speed limits. But the free response is the practical road test. You have to prove you can actually parallel park the car while clearly explaining your mirror checks to the instructor sitting right next to you.
That driving test analogy is perfect because that 50-50 split is incredibly intentional. It tells you immediately that rote calculation and rapid-fire recognition.
Which is what multiple choice usually tests.
Right, that's only half the battle. The other half demands deep, articulated reasoning. You cannot pass this exam just by being a good guesser who plays the odds on multiple choice.
Right.
And you cannot pass it just by being a slow, methodical philosopher who writes great essays but can't crunch a number. You have to demonstrate both skill sets equally.
Knowing what you can bring into the room is one thing, but survival really depends on the rules of engagement, which are highly specific. On test day, students are provided with a formula sheet and statistical tables.
Which is a huge relief.
Yeah, so you don't have to memorize every single complex multivariable equation, but you must bring your own graphing calculator with statistical capabilities.
That's non-negotiable.
Right. And looking at the list of prohibited items, I noticed something brilliant. They explicitly ban devices with QWERTY keyboards, mini computers, and electronic writing pads. When I first saw that QWERTY keyboard ban, it hit me. This isn't some arbitrary anti-technology rule. It's about stopping people from bringing in a digital filing cabinet.
If we connect this to the bigger picture, you are exactly right. Analyzing exactly why those specific items are banned tells you a lot about the integrity of the test. A QWERTY keyboard allows for rapid text entry.
You could just type out everything.
Exactly. It means a student could theoretically type out and store massive amounts of pre-programmed notes, definitions, or entire textbook chapters right there in the device's memory.
Just a total brain dump before the test begins.
Right. And the exam is designed to test your statistical reasoning and your real-time processing power. It is not testing your ability to access a digital archives or connect to the internet. By banning QWERTY keyboards and mini computers, the test makers isolate the exact variable they want to measure.
Your actual brain.
Your brain's organic ability to analyze data.
That makes the structure feel much more like a psychological evaluation than a simple math test. Which brings us to the first half of the assessment. Section 1, which is essentially a multiple-choice gauntlet.
It is intense.
The numbers game here is wild. You face 40 questions and you have exactly 90 minutes to answer them. As we mentioned, this makes up 50% of your total score. Doing the basic math on that, 90 minutes for 40 questions, you are looking at just 2 minutes and 15 seconds per question.
That pacing is ruthless when you consider the cognitive load.
2 minutes and 15 seconds.
To read a complex, multi-paragraph statistical scenario, identify the trap answers designed to trick you, do the mental or calculator-based math, and lock in a choice. It requires immense cognitive agility.
Yeah.
You are constantly switching contexts from one abstract problem to the next. 1 minute, you are calculating the probability of a defective light bulb.
And 2 minutes later, you're analyzing the standard deviation of a sample of penguin weights.
Exactly.
To survive that kind of whiplash context switching, the exam targets 4 core skill categories in this section. Skill 1 is selecting statistical methods. Skill 2 is data analysis. Skill 3 is using probability and simulation, and Skill 4 is statistical argumentation. Looking at how these are structured, I can see a clear progression. First, you have to select the method, meaning you have to look at the messy, real-world problem and figure out which mathematical tool to pull out of your toolkit.
Step 1.
Then comes data analysis, which is actually using that tool to crunch the numbers.
Precisely. And then probability and simulation involve understanding the underlying mechanics of chance that govern those numbers. But what is truly revealing here is Skill 4, statistical argumentation.
Even in a multiple-choice format.
Exactly. The fact that argumentation appears even in a multiple-choice format shows that they want you to evaluate conclusions quickly. You aren't just calculating a final number, you are often selecting the multiple-choice option that best explains why a certain claim is mathematically valid or invalid based on the data provided.
This is where we need to have a serious strategy session based on the source material. The guide breaks down exactly how much of each course unit is tested in this multiple choice section.
This is the golden information right here.
If you want a masterclass in how to allocate your cognitive resources and study time, this is it. Let's group the heavy hitters conceptually.
Let's do it.
Unit 1, which covers exploring one variable data, is the absolute biggest chunk of the test. It makes up 15 to 23% of the multiple choice section.
That is massive.
It covers the absolute bedrock basics. How to read a histogram, finding the mean and the median, understanding standard deviation and the spread of a single variable.
That is a massive footprint for a single unit.
Yeah.
It tells you that if you do not deeply understand how a single variable behaves, you are going to bleed points right out of the gate.
You'll just hemorrhage points.
Exactly. As a study strategy, you must master Unit 1. It is the foundation that everything else on the exam relies on. You can't run complex inference models if you don't know how to find the center and spread of your data.
Right. And following right behind that, we have the other major pillars of the exam. Unit 4, covering probability, random variables, and probability distributions, makes up 10 to 20%.
Another heavy hitter.
Then we have inference. Unit 6, inference for categorical data. Proportions is 12 to 15%. And Unit 7, inference for quantitative data, is 10 to 18%. Rounding out the heavy hitters is Unit 3, collecting data, at 12 to 15%. If you think about it, inference is the real magic trick of statistics. It's how we take a small sample, like polling 1,000 people.
And use it to confidently predict the behavior of an entire country.
Exactly.
That is exactly what inference is, and it is why those units are weighted so heavily. The test makers are sending a clear signal about prioritization here. Understand your basic single variable, understand how to design an experiment to collect your data properly without bias.
Very important.
Understand the probability that governs that data, and then know how to run inference on your means and proportions to make a real-world claim. If you allocate your study time based purely on these percentages, focusing deeply on just those 5 units, you are mathematically securing the vast majority of your multiple choice score.
Which brings us to the units you should definitely still know, but maybe shouldn't lose sleep over if you were cramming at the last minute. The minor leagues. Unit 5, sampling distributions, is 7 to 12%. Unit 2, exploring two variable data, is 5 to 7%. And then we have the absolute smallest slivers. Unit 8 covers chi-square, which is essentially how we test if there's a significant relationship between categorical variables,
Like checking if a casino's die is actually loaded.
or if a coin is genuinely fair. But that complex unit only makes up 2 to 5% of the test. And Unit 9, inference for quantitative data, slopes, is also just 2 to 5%.
This is where that strategic mindset is crucial for you as a learner navigating any massive body of information.
Yeah.
Imagine spending 3 weeks agonizing over the incredibly complex multi-step formulas for chi-square and inference for slopes,
Just pulling your hair out.
only to find out they combined make up at most 10% of the multiple choice section and possibly as little as 4%. Understanding these weights is the ultimate defense against information overload. You simply do not study the slope of a regression line as hard as you study basic one-variable data. You let the architecture of the exam dictate your preparation strategy.
Once you survive that 90-minute multiple-choice gauntlet, the whole format of the exam shifts entirely. We put away the rapid-fire scanning and enter Section 2, the free response questions, or FRQs.
A totally different beast.
This section has 6 questions total and makes up the other 50% of your overall exam score. But it's divided into 2 highly distinct parts. Let's look at Part A first, which consists of 5 questions with 65 minutes allotted.
Okay.
This Part A alone is worth 37.5% of your overall exam score. But what is truly amazing here is how structured and predictable this section is.
The certainty of that blueprint is an absolute gift to the test taker.
Yeah.
In life, we rarely know exactly what challenges are coming our way, but here, the evaluators are handing you the map.
They really are. We can call these the predictable 5. The guide explicitly states that there is exactly one multi-part question primarily focused on exploring data. There is exactly one multi-part question primarily focused on collecting data. There is exactly one primarily focused on probability and sampling distributions. There is one question primarily focused on inference.
And one more.
And finally, there is one combo question that mixes 2 or more of those skill categories together. You walk into the room knowing exactly what 5 domains will be on those pages.
But the catch is in the execution. Because knowing the topic isn't enough to secure the points. The source material lays out a critical rule for this section. At least 3 of these first 5 questions will heavily assess your ability in statistical argumentation.
You can't just write down a number and circle it.
No, absolutely not.
So what does this all mean? It means that simply doing the math correctly is not enough to get full credit. You might punch the numbers into your approved graphing calculator flawlessly.
You might find the perfect standard deviation.
But if you cannot write a coherent, grammatically correct sentence explaining why you chose that specific statistical method, or defending your final conclusion against a hypothetical counterargument, you will lose points. You have to step out of the role of a human calculator and step into the role of a data advocate.
Statistical argumentation is entirely about communication. It is about proving that you can advocate for the truth hidden inside the numbers. In the real world, a beautiful spreadsheet means nothing if you can't explain to a boardroom of non-statisticians why that spreadsheet proves they need to change their business strategy.
No one's going to listen to you.
Exactly. That is what those free response questions are training you to do.
And you are going to need all of those advocacy skills. Because after you finish those 5 questions and you are exhausted, you arrive at the absolute climax of the exam. Here's where it gets really interesting. We are talking about Section 2, Part B, Question 6, otherwise known as the investigative task.
The investigative task is legendary among students and educators alike, and for very good reason. It breaks all the rules you just got comfortable with.
Let's break down the sheer intensity of the waiting for this one single question. You get a full 25 minutes allotted just to answer question 6 alone.
25 minutes for one question.
And this single problem is worth a massive 12.5% of the entire exam score. 1/8 of your overall grade comes down to this one 25-minute window at the very end of a 3-hour marathon.
It is the ultimate test, the final box of the exam.
Yeah.
And we have to ask why it commands so much time and such a massive percentage of the score.
Right. Why is it so heavily weighted?
The source explains that the investigative task assesses multiple skill categories and content areas at once. But the true crux of the challenge is this. Students must apply their statistical reasoning to unfamiliar contexts or non-routine problems.
Unfamiliar contexts and non-routine problems. That has to be incredibly intimidating. You just spent a year studying a very specific, rigid syllabus. You know exactly how to test the probability of a coin flip or the inference of a political poll.
The predictable stuff.
And then you turn the page to question 6, and the test makers throw a scenario at you that you have never seen before. Maybe it's analyzing the mating habits of an obscure deep-sea fish using incomplete, strangely formatted data metrics that aren't in any textbook.
Right.
It is basically the test makers trying to see what happens when the data refuses to fit into the neat little boxes you memorized.
This raises an important question. How do you study for the unfamiliar? How do you prepare for a scenario that hasn't been invented yet? And the answer is, you can't memorize your way through it. This task is the ultimate synthesis of those 3 big ideas we talked about at the very beginning of the deep dive.
By the time you reach question 6, your brain is fatigued. You've been crunching numbers and writing arguments for nearly 3 hours, and then you are faced with the absolute unknown.
Rote memorization will absolutely fail here. If you only learn the steps without understanding the underlying mechanics, you will freeze.
You'll just stare at the page.
Precisely. The evaluators want to see genuine statistical adaptability. They want to know when the rules seem slightly bent, or that context is a scientific field you know absolutely nothing about. Can you still rely on the fundamental laws of variation, probability, and inference to navigate your way to a logical conclusion?
It's the ultimate stress test.
It is. The investigative task separates the students who merely learn the choreography from the students who truly understand how to dance. It measures your ability to transfer knowledge into a chaotic environment.
That is such a powerful way to look at it. Let's do a quick recap of the architectural journey we've just been on. We've decoded a remarkably well-designed challenge. The AP Statistics exam is a 3-hour crucible that tests completely different gears of your brain.
Really distinct gears.
First, it tests your rapid-fire problem solving and your ability to context switch in the 90-minute multiple choice section, forcing you to leverage your knowledge of heavily weighted topics like one variable data and inference.
The predictable 5.
Then, it completely shifts gears into deep argumentative reasoning in the free response section, demanding that you clearly communicate and defend your math in written English. And finally, it culminates in the ultimate test of cognitive adaptability, the 25-minute investigative task, where everything you thought you knew is applied to something completely alien.
And this is why mastering the structure of this exam is so much more than just a way to pass a college-level test. The evaluators have basically built a scale model of the modern information age.
Oh, that's interesting.
Think about it. We're constantly bombarded with multiple-choice-style rapid-fire data points on our social media feeds and news alerts, where we have mere seconds to assess if a statistical claim is valid or if it's a trap.
Just constant context switch.
We are then asked to articulate and defend our positions in our careers or in debates with our peers, much like the free response section. Learning how to navigate this exam builds a profound mental framework for making sense of a complex, noisy, and often misleading data-driven world.
It really is training for reality. It teaches you to look for the structural weights of the problems in your own life. And as we wrap up our deep dive today, we want to leave you with a final thought to mull over. Something that builds directly on the fascinating philosophy behind question 6, the investigative task, but looks toward the future.
I love this.
We live in an era where artificial intelligence can now easily ace the multiple-choice gauntlet of any standardized test. An AI can instantly calculate standard deviations, run complex inference models, and generate perfectly structured statistical arguments in seconds.
Without breaking a sweat.
If algorithms can do all the heavy lifting of the predictable 5, it begs a bigger question about the future of human knowledge. Will the ability to tackle the unfamiliar context of the investigative task soon become the only valid way left to measure uniquely human analytical intelligence?
That is the question.
If machines handle the routine math, our true value might solely rely on our human adaptability when facing the completely novel, weird, and messy data sets of the real world. Something to think about next time you let an algorithm interpret the data for you.
It is a phenomenal question to keep front of mind as the landscape of intelligence, both human and artificial, continues to evolve.
Absolutely. Thank you for joining us on this deep dive. Keep questioning the data, keep looking for the patterns, and we will see you next time.